Hello everyone, welcome again in Eng-Man YouTube channel. Right now we are going to do decline curve analysis. A particular friend from LinkedIn asked me to do this analysis and that's we are going to do today. All right, so we have provided the data. Here we have the month of the production and then the oil production rate. They should be in stock tank barrel per day, I guess. All right, so we have the data. We need to determine the type of the decline, whether it is exponential, hyperbolic, or harmonic. And then we need to determine the decline rate as well as the B factor. And lastly, we need to perform the production forecast. All right, before we start doing the job, we need to review a bit about the decline curve analysis. All right, so for the determination of the decline model or the decline type, we need to check about it first. All right, for exponential decline, we can obtain if the plot of logarithmic of rate versus or against time or rate versus cumulative oil production shows a straight line and in accordance with the respective equations, these two equations, then the decline data follow an exponential decline model. All right, so if you have the data, you can create these plots, okay, semi-log rate versus time or linear scale or linear plot of oil cumulative production against rate. If you have or if you obtain linear relationship, then it means that you will use exponential decline. All right, your well or your reservoir performs with exponential trend. And also the other extreme is the harmonic decline. If the plot of log Q or log rate versus log time or NP or cumulative oil production versus logarithmic Q shows a straight line and is in accordance with the respective equations, then the decline data follow a harmonic decline model. All right, the same thing. You can create this log-log plot or semi-log plot, and if you get straight line, it means that your well or your reservoir is performing under harmonic trend. And lastly, if no straight line is seen in these plots above, the model may be hyperbolic decline model. All right, so I hope it's clear. So this is the thing that we will do to determine whether or not we have exponential decline or harmonic decline or hyperbolic decline. All right, so let's go. This is the data that we have. First, I want to plot with linear scale plot. Okay, right click, select data, add. For the horizontal axis, we plot month, whereas for the vertical axis, we plot the rate, and then we have this plot. All right, so far so good, but we need to check the data first again to make sure there will be no problem. All right, you can see the trend, but I'm a bit curious about the last data that we have. As you can see in month 96, our flow rate is 3,000, above 3,000 stock tank barrel per day. But at the next month, the flow rate drops significantly down to only 1,300 stock tank barrel per day, right? It seems unnatural. Maybe there is an abrupt formation damage, severe formation damage abruptly, or maybe there is a operational problem, well problem, maybe artificial lift problem, maybe an operator chokes back the well. We don't know. But the data shows there was a significant decrease of production, which seems unnatural. And in my opinion, it's not, the decrease is not because of the decline trend of the reservoir. And of course, the last 2 points, there is no production there. And it means that we cannot include those three data in our plot because it will disturb the decline curve analysis. So at this point, we need to do data cleaning. We click the plot, and then we don't include those three data, right? So the representative last performance of this well will be at this row. And then if we want to do production forecast, we should start from this value rather than this value, because this is, we are still uncertain why the production rate dropped down to just only 1300 stock time barrel per day. All right, so I hope it's clear. So we have the plot, and then of course, based on the procedure that we have discussed previously, we need to plot it first on a semi-log scale. All right, I'm just going to copy the plot and then right click on the y-axis, format axis, and then we select logarithmic scale. We obtain this plot, and as you can see, we have straight lines, right? Or maybe we have straight lines. Let me show you. First, we can take this, this shape, straight line, and then I'm just gonna modify the line a bit. The first straight line, as I see it, is at this period. Okay, this is the first straight line as I see it. Of course, the decline curve analysis depends on the engineer who does the analysis. All right, so it's a bit subjective, but it's okay. I hope you can see the thing that I see right now. So this is the first straight line, this period, and then there is an increase in decline trend. And then the second period with higher decline is at this period. I'm going to use green. All right, so you can see the first period, the lower decline, and then the second period, the higher decline. All right, and then I'm gonna separate the period with a black line like this one. We don't know what caused the change in decline trend, right? But maybe there is a well problem, or maybe the reservoir pressure drop due to increase in production in some other wells. We don't know, but the decline trend changes like this one. And let's say if we want to extend or extrapolate this profile, we can just do like this one, and then extend like this one, and then dashed line, something like this. The same trend or the same gradient. Yeah, you can see there is a drop in production from the original trend down to this trend. All right. On the same way, if we want to forecast it, then we can also do something like this, just to visualize the forecasting. All right, like this one. Okay, so I hope it's clear. We have an exponential decline curve. When we plot it on a semi-log scale, logarithmic flow rate against time, it shows a straight line. So it means that we have exponential decline curve. This is the first step. So to answer the first question, it is exponential. All right, of course, you can try another plot, but for me, I'm okay with this result. If I have a straight line in a semi-log scale, log flow rate against time, that it means that I have an exponential decline trend. All right. So far, so good. And then the next question, determine the decline rate and the B factor. Of course, the B factor will be 0 because we have exponential decline. So the B factor is 0, and we need to determine the decline rate. Okay, it will be interesting. So I'm going to copy the plot first again. All right, we start from this plot. I'm going to show you two ways to determine the decline rate. The first approach is by concentrating first on this period, okay, on this period. Okay, we first check the point. You can just point your cursor here. It shows this, the data series will be 59 and then around 22,000. All right, so or maybe 60 and 60 the month number 60, and then the flow rate around 22,000 stock time barrel per day. So I'm gonna take the data again, select data, starting from the month 60, right? This one down to the bottom of data, of course, down to month 96. All right. Also, the flow rate. So we are going to have this plot, okay? The original data and then the data that only concentrates on the second period, because we want to do forecasting using this period. And also we want to do the fitting, data fitting to determine the decline rate using the period. And then we can also again copy the plot, delete the original data, and then we will focus on this period only. Okay, the first approach to calculate or to determine the decline rate is very easy. Just do right click on the data and add trend line, and then we select exponential, and then we display the equation. All right, we improve the size, we increase the size. All right, so as you can see the equation here. All right, this is actually the decline rate. Right, this is actually the monthly decline rate. So decline rate DI is 0.055 per month, and per year just multiply it with 12. All right, so far so good. And also if you want to represent them in percentage, so we have decline rate of 6% per month or 66% per year. All right, why can we do this kind of determination or calculation? Because if you can see here, right, if I borrow the equation and then you see the equation for exponential decline is the flow rate at any time t equals to the initial flow rate times or multiply with exponential of the minus initial decline rate multiplied by time. All right, so this is actually shows the same pattern with the equation that we have obtained from the trend lining or from the regression. All right, so this is actually the initial flow rate of this plot. So if you extrapolate the plot like this one, let's say I'm gonna do a modification a bit. Okay, so if you extrapolate until it intercepts the vertical axis, it will give us this value, which is analog to the initial flow rate shown by this equation. All right, so y represents the qt, or flow rate at any time. This number represents this initial flow rate. And then, of course, this exponential, this is the initial decline rate. And x actually is t, or time, or month in our plot. So this is very easy. You can just do the trend lining from your spreadsheet, and then you get the initial decline rate. All right. So you can take this approach, you can do this, and of course you can get the initial decline rate. All right, so far so good. I hope it's clear for you, right? And then of course the second approach, we will do the analysis using solver in the spreadsheet. Okay, it's a bit more like the least square approach, but I'm not going to do least square approach in this particular example because I think it's quite tedious. So I'm just going to do my way. But actually my way is quite easy. You can follow me. All right. Okay, so we can save what we do until now first, and then we can copy. We make another sheet. All right. So let me delete everything else. Okay, I'm gonna preserve this one and also the first result. All right. So what we are going to do now is we will make a forecast, or maybe a simulated result. So this is, I'm gonna type in actual oil, and then it is calculated oil. All right. We started from the month 60, right? So I'm gonna freeze everything first at this point. Freeze paint. All right. So we start on the month number 60. All right. So this is our initial flow rate. I'm just going to use this value, 22,000, as our initial flow rate. Okay. And then just take them down to make it clearer for us. And then, of course, we do the exponential forecasting starting from this initial flow rate. Let me take the equation and then put it up there. All right, so the flow rate at any time is initial flow rate. Press F4 because we are going to use it again and again. Multiply with exponential of this one, initial decline rate. But at this point, we don't really know what the decline rate will be, right? Because we do this at the assumption that we haven't done any analysis. But let's start using a guess value. Okay, I'm gonna make a guess. And let's say we guess the initial decline rate will be close to this value, right? This is the correct value, 6% or 5.5%. But let's say we don't know the result, so we make a guess, 5% per month, and we are going to use this guess value to make a forecast. Okay, so flow rate at any time is initial flow rate, F4, multiplied by minus this one, initial decline rate. We are going to use it again and again. So press F4 again, times month. Okay, so month or time is month subtracted by the previous month. And of course, we started from month number 60. So the time will be that time subtracted by month number 60. Okay, and then close. All right. And then we just drag them except those three. All right, so these are the calculated value using the exponential decline curve analysis with this initial decline rate, the guessed initial decline rate. Of course, we need to do the further analysis to correct it. Okay, so we are going to do the error analysis. The error will be absolute value of the actual flow rate, all right, subtracted by the calculated flow rate, all right, and then divided by the actual flow rate, make it multiply by 100. Of course, we start from zero error because this is actually the same value. Okay, all right, so far so good. And then we sum up all errors. Okay, it will be sum of all errors. So okay, so this is the cumulative errors of our decline curve analysis. Of course, we want to make the sum of the errors minimum in order to achieve a correct decline trend. Okay, so again, let's make a new plot, or maybe just delete the plot, and then we make, this is the actual data, and then we also plot the calculated result. Select data, this is the calculated, and then the series will be starting from month number 60 down to month number 96. We do that also for the calculated flow rate. All right, so this is the data, or this is the actual. All right, let me create the legend first. All right, let's focus on, okay, and then also for this one we concentrate. All right, okay, so the dark red line is the actual data, and the blue dots, all right, the blue dots are the calculated point. As you can see, we achieve quite a good match, all right, but of course we are not satisfied enough, so let's do the optimization using solver in Excel, okay, to minimize the sum of the errors. It's actually a bit like least square approach, but yeah, I don't know, the least square approach, I think it's quite tedious. We should follow the formula, and I think it's more comfortable for me to do this kind of analysis. All right, so go to data, and then we use solver in Excel. All right, set objective, the objective that we want to modify, of course, the sum of the errors. We want to make it minimum. So we select minimum by changing what? By changing the decline rate that we guess. initially, which is the 5% value, okay, by changing variable cells. All right, so let's solve it. Okay, so the sum of the errors decreased from 340 down to 329. So this is the minimum errors, the minimum cumulative errors. And as you can see, we achieve a better match. All right, let's see, right. You see, the decline rate is actually 5%. Let's expand the value, 5.3%. All right, so this is the correct value according to this approach. Let's make them bigger. Okay. All right, so let me recap. For the second question, the determination of the decline rate and the B factor. And of course, the B factor is 0 because it is an exponential decline. And for the initial decline rate, the first approach we do is just by doing a trend lining. All right, we display the equation in Excel and we obtain the initial decline rate is 5.5%. All right, let's expand it. And then the second approach, we do something like least square approach. We obtain the errors between our actual data and the calculated value. And then we sum all the errors and then we minimize the errors to obtain our true or correct initial decline rate. So as you can see, the two values, the two decline rates are close enough, 5.5% from the first approach and 5.3% from this approach. So this is actually the correct value. So decline rate will be 5.3% to 5.5%, or whichever do you like, right? You can say 5.3% or 5.4% or 5.5%. It's okay because actually it's quite subjective. It also depends on the period that you select to do the fitting. All right, so this is actually the thing that we do is called fitting approach. All right, so far so good. I hope you enjoy until this far. And of course, lastly, we will do the production prediction, and it is much simpler compared to the second thing that we have done. All right, so let's again copy the sheet, name it forecast. All right, and we will start the forecast using this already calculated value. And actually this calculated value use initial decline rate of 5.3. So okay, I'm just going to use this 5.3 value for the forecasting. And okay, let's expand the number. Let's say up to 120. Okay, so just do this. All right, and then to make sure, we make the plot. Copy first, and then this one we delete, and then we make something that we call forecast. Okay, the X of course starting from 97, the month, down to 120, and then the flow rate also. All right, so this is the forecast. Let's expand the scale. Of course. So this is the plot. Let's say we want to start from month 0 and we plot also the other actual data. Actual also series, of course, starting from month number 1 down to month number 95. We do that also for the flow rate. All right. Okay, so everyone's happy. So this is the result. You can see this is the actual production period. All right. This is actually the historical data, and then this is the forecast value. You can also copy it and then create it on a linear scale. Right click on this vertical axis, format axis, and uncheck the logarithmic scale. All right. So this is the plot that we have right now. This is the production period. I mean, this is the historical period, and this is the predicted or the forecasted period. All right, so I hope it's clear and I hope you enjoy the video. I hope you can take something from this tutorial. So let us recap everything. So in this video, we have done decline curve analysis. We have the data. To determine the type of the decline trend, we need to plot the data. And then because we have a straight line, when we plot the data on a semi-log scale, the vertical axis is the log rate and the horizontal axis is time in month. So it means that we have exponential decline. All right. Exponential decline means that your B factor is 0. And then we calculate the initial decline rate. We have done two approaches. The first approach is by doing the trend lining and then get the initial decline rate from the display of our equation, 5.5%. And then the second approach is a bit like least square approach, where we do the forecasting using exponential decline analysis. We use the guess value, which is 5%, and then we do the error analysis. We sum all the errors and then we make the errors minimum to have the correct value of initial decline rate, which is 5.3%. And lastly, using the corrected or the true initial decline rate, we do the forecasting to obtain this production plot, both for the historical and for the forecast value. All right, so I hope you enjoy everything that we have done so far. Please don't forget to subscribe, like, and share to your friends or connections. And see you again in the next video. Thank you.